finding the domain of a function. Okay? And so when we're finding the domain of a function, so the domain again, let's just do a quick reminder. The domain of a function are all the values of x that are where my function is actually defined. It's basically, the short answer is all the x's that I'm allowed to plug in, okay, that don't make my function undefined. And so there's two ways that domain can be explained. Okay, so first of all, it can be described explicitly. Maybe you have f of x equals x squared and they only want you to use x greater than or equal to 0. This is an example of the domain being explicitly defined. It's basically set out. Somebody wrote down the function and said, you can only use these x values. Okay? Now, a lot of times what we find is they're implied. And so when they're implied, then we kind of have to know what real numbers that we can use for which our expression is defined. Okay? And so one of the ways that we can, so there's some things that we're looking for that cause domain restrictions. So the first thing is sometimes we have a word problem. And basically this is a contextual issue. So let's say that my function, f of x, was describing some process where it was trying to predict the cost of producing a certain number of boxes, where x was the number of boxes. So we have some function here, and f is stated here, and it's stated somewhere in the words that x is the number of boxes that are produced. Okay, when you think about a manufacturing company producing boxes, it only makes sense that the boxes there would be a positive number of boxes, right? I've never heard of anybody talk about, well, I'm going to go make -3 boxes. Okay, so this is a contextual issue based upon the context of the problem. Right, so the ones that we're going to run into a little bit more often are when we have things, we know that there's certain things that we're not allowed to do in math, and we've discussed them before, and one of them is to take the square root of a negative number. Okay, so this is an undefined situation. We'll make that a specific number because if a is negative, it actually does work. So the square root of -3 is undefined, and so this is the type of thing that we're looking for, is for things that we're not allowed to do. So whenever I see something with a square root in it, or any sort of root, I always want to look at it really closely. We'll explain how we're going to do this more specifically. And then another situation that we've talked about already in here is division by 0 is another undefined. So taking the square root of a negative number is one possible thing that will give us a domain restriction. The other one is division by 0. So whenever there's a possibility that these two things could happen, I need to look very closely at them. Okay, so let's look at f of x equals the square root of x plus 4. So I have a square root. That immediately tells me I need to be thinking to myself, I know that I'm not allowed to take the square root of any negative number. The square root of 0 does in fact exist, right? You can take the square root of a negative number. So the smallest number that I could put in here, if I used x equals -4, that gives me the square root of 0. And that is a thing, if the square root of 0 is in fact 0. And so I need a way to figure out how I can write my domain, right? If I plug in something like -8, I can see right away that -8 plus 4 is going to give me -4. So how do I figure this out? So, and this applies to any even root, not to an odd root like the cube root, but the square root and the fourth root, they all have to be positive, the numbers that we put into them in the real number system. So we take this out and we set it greater than or equal to 0, because again, I said -4 is possible, right? I can plug in -4 because -4 plus 4 is 0. And then I just solve this. So x is greater than or equal to -4. I just solve this inequality just like it's an equal sign. The only time I have to worry about anything other than that is if I'm dividing or multiplying by a negative number, and then in that case I have to flip the sign. So this gives me a domain restriction of x is greater than or equal to negative 4. That's my domain restriction. So I'm allowed to use any number to put in here as long as it's greater than or equal to negative 4. So anytime I see an even root, I pluck what's underneath the radical out and I set it equal to greater than or equal to 0. I solve that. That's my domain restriction. All right, so let's look at a possible division by 0. So I have f of x equals x plus 1 in the 1 over x plus 1. So if I just had 2 in the denominator and my x was in the numerator, I wouldn't have to worry about my domain restriction, because if I just have a number down there, that can't equal 0, it's just a number. But if I have a variable in the denominator that could possibly make my whole denominator equal to 0, then I need to throw that point out. Okay, so I'm allowed to use anything else, right? If I use 3, then I get 1 over 3 plus 1, which is 4. So I get 1/4 here. So I'm allowed to use all the other numbers. It's just that if x plus 1 is equal to 0, that's when my problem falls apart, because that's when I'm dividing by 0. So I find out here that x equals negative 1 by solving for x. That means here that my domain basically is all real numbers except x equals negative 1. Or I could say x cannot equal negative 1. Right? Those are both my domain restrictions. It's okay for me to use anything else. Right? I can use a negative number. If x is negative 2, then I would get 1 over negative 2 plus 1 would just end up giving me negative 1, because negative 2 plus 1 would be negative 1, and 1 divided by negative 1 is negative 1. So everything except for that negative 1 I'm allowed to plug in. So these are our two main ones, when I have an x in the denominator and when I have an x in the radical. Now, this is assuming that I have basically my equation solved either for f of x, right, or y is interchangeable. So I want to probably do that first, because then it's easiest to see what my domain restrictions are. Once I have f of x notation, then if I have a square root, I approach it like this. If I have an x in the denominator, I approach it like this. All right, so let's make things a little bit more interesting. Let's do a little bit of a combination here. So what if I have f of x equals 1 over the square root of x minus 1? So I have a little bit of both, right? So I have both this square root problem, and I have a variable in the denominator in my problem. Okay, so I need to approach this one with a little bit more care. So first of all, when I'm doing a square root, right, I see the square root, I immediately know that x minus 1 has to be greater than or equal to 0. If that would be true, if f of x was just x minus 1, x would be greater than or equal to 1, and I would be good to go. This is my domain. Okay? However, now I have the square root of x minus 1 in the denominator. And in my denominator, I know I'm not allowed to divide by 0, right? So this one goes with this here. So what I need to do over here is a very similar. I know that this has to be greater than, my square root has to be greater than or equal to 0, but because I'm in the denominator, it means that I could strictly have to be greater than 0. Because it's in the denominator, I know I'm not allowed to divide by 0. So I have x is strictly greater than 1 here. So a little bit different, where this one I'm allowed to plug in 1, this one I'm not, right? I can use everything just a little bit bigger than 1, but not 1. So my domain restriction on this one is x is strictly greater than 1. If I just had the square root of x minus 1, it would be greater than or equal to 1. All right, so let me do one more interesting example. What if I have x minus 2 in the denominator, and x is x plus 3. Okay, so what I can do here is I have two different things here, okay? So again, I have in the denominator the square root of x plus 3. I know that for a square root, I know I need x plus 3 is greater than or equal to 0, but again, it's in the denominator, so I can say it's strictly greater than 0. So now I have x plus 3 is greater than 0, and I have x is greater than -3 is my answer. And this is my domain restriction here. If I'm given any other function, for instance, I have x squared plus 4x minus 6, or f of x equals 3x minus 2, I look at these and I can see that I don't have a square root, right? No even root, and I don't have any division by any variables. And so for these, I can immediately say that my domain is all real numbers. This is just a symbol for all real numbers. Okay? So once I have it, if I have f of x notation and I have f of x is equal to something or y is equal to something, I can immediately say that if there isn't a square root or there isn't a division by a variable, then I can see that it's all real numbers unless someone explicitly states underneath it that I can only use these x values. All right, so let's just do one that's words. So let's look at the volume of a sphere. Okay, and the volume of a sphere is 4/3 pi r cubed. All right, so this time my r is my variable. So since I'm talking about the volume of a sphere and my r is my radius, then as my r has to be greater than 0 or else I don't have an actual sphere, right? And I've never seen a sphere with a radius that's negative. So this is kind of one of the implied ones where if I just looked at this and I had no idea what it was, I would say, oh, there's no domain restriction because there's no square root, there's no divisible division by the variable, but it is the volume of a sphere, and I can only have a sphere if I have a positive radius. So in this case, my r would be greater than 0 is my implied domain in this case. All right, I hope that clears up any domain issues, and we will talk about 1.2 next time.